Assalamualaikum and hi everyone, I am Siti Islina and today I will present my final year project with the title The Measurement of Indoor Air Quality at Faculty of Applied Sciences Office. This is a table of content for this presentation. Firstly, background of the study. UiTM in Shah Alam have many buildings and departments. Office at Hal Ehwal Academic and Dean Office has been chosen to conduct this study. There are different number of staff at each office that will lead to different data of indoor air quality. About 81% office workers spend between 4 and 9 hours per day at their desk. Any contaminant that come from variety of sources could pose to risk of human health. To identify the factor determining air quality and creating ideal workplace for the staff, the important to conduct air quality monitoring to prevent any adverse impact and create good indoor air quality. Next is problem statement. As a workplace, the indoor air quality is likely to play a significant role in the design of future office building and building service system. The staff look forward to the comfort and safety of the office regardless of the type of safety, such as physical or chemical hazard. If people do not take precaution when working, accidents are hardly likely. In the study, carbon monoxide, carbon dioxide and volatile organic compound are being measured. CO2 is the main air pollutant that come from a variety of sources. Volatile organic compound that come from some chemicals such as pesticide, pest control activity need to be assessed the value in order to do a management control. Carbon monoxide as colorless and toxic gas can silently kill us before we are aware it is in our home. For the objective, there are three which are: first, to determine the level of pollutant, carbon monoxide, carbon dioxide and volatile organic compound. Second, to compare and identify the dangerous value of indoor air quality in both offices. Lastly, to evaluate the occupant comfort in relation with temperature and relative humidity. Significance of study. Firstly, the finding of this study will benefit to users that use any office, especially for small buildings, considering that indoor air quality is very important to lower the risk of developing a variety of chronic illness. In addition, the study will benefit to Ministry of Health and local authority as a baseline data. It also has significant potential in the field of environment management system, also in science and technology. In addition, it helped to create awareness of indoor air contamination at the office. The hazardous substance that they may inhale could pose to health effect, whether in the short term or long term. These were the methodology used in conducting data collection of indoor air quality. These are the questionnaire that was used to conduct occupant comfort. The concentration observed in Dean office is high during 10:05 AM and low during 11:55 AM. On comparing with HEA office that showed the highest value during 10:45 AM and lowest during 12:05 PM. The reason of the high value of carbon monoxide in the Dean office was because during that time the staff was using water heater and the measurement placed quite near to pantry. According to Chemscape Safety Technology, supplemental heater can expose people to carbon monoxide throughout the winter. The variation of carbon dioxide values in both offices, especially in Dean office that has the highest value at 11:15 AM and the lowest at 9:55 AM, while in the HEA office shows the highest was at 11:35 AM and the lowest at 10:05 AM. Both offices do exceed the standard limit of carbon dioxide stated by ASHRAE. The value at Dean office were quite higher than HEA office across time. At Dean office and HEA office have the highest value were at the beginning of the data collection, which at 9:55 AM with the value were 1.22 ppm and 0.98 ppm respectively. Compared to standard value or acceptable limit of volatile organic compound, the data collected in this study were within acceptable limit. Different occupant, staff or any visitor that enter both office have a different scented perfume and it gave a different value and also it related with the number of occupants. The relative humidity data from both office show an unstable data while the temperature show big difference. The formula for humidity and temperature simply state that they are inversely proportional. According to Health and Safety Executive United Kingdom, thermal comfort is unaffected by relative humidity level ranging from 40% to 70%. The temperature was collected from Dean Office showed that the value was within the recommendation from Department of Standard Malaysia, which are between 23 degrees Celsius to 26 degrees Celsius, while for HEA Office the temperature were not in the range. Neutral condition in Dean Office was higher than HEA Office. The reason why HEA Office contribute to low comfortability is because the temperature in that office was not in the standard range. With the number of occupants that differ in certain time, it also contribute to the changes of the temperature. The occupant satisfaction was analysed. In the Dean Office, 18% are satisfied with the current condition, but for HEA Office, only 40% were satisfied. As a conclusion, multiple indoor contaminants were found during an indoor assessment of University Building Office, and the measurement of the air pollution in that revealed that prolonged exposure to this pollutant may have negative health impact. Indoor air quality was evaluated inside 2 offices using sensing indoor and midterm monitoring of volatile organic compound, carbon monoxide and carbon dioxide concentration with the aim of furthering the problem. When the number of occupants is extremely high, the carbon dioxide concentration value for both offices do not meet the requirement of ISO Standard 62-2001. Although the carbon monoxide and volatile organic compound concentration values did not exceed the requirement, it is nevertheless important to monitor the permissible level of both pollutants in order to avoid future issues. Thank you, that's all from me.